Hey guys, it's Mr. Hanson404 at Mr. Hanson404. Subscribe. Today we're going to talk about inequalities. Inequalities are different from an equation because an equation might have one answer, whereas an inequality is a bunch of things. So like for example, if we go to Six Flags and they say you must be at least 48 inches to ride the ride, that means you have to be 48 inches. So you could also be 49 inches, you could be 60 inches, you could be 72 inches. On and on and on. There's more than one answer, so it's a range of values that make it true. So for example, if we were going to write this out, we would say x, which is x is your height in inches, and that would have to be greater than or equal to 48. So what this means is x could be any number, right? Any number, that's what a variable represents, an unknown value, and it must be greater than or equal to, that's what that line means, that it could be equal to 48. So to see if it works, you take these numbers that we're working with and you plug them in. For x, you substitute them and you see, does this make a true statement? If it is, it's a solution to the inequality. Now, what if you were 47 inches? 47 is not greater than or equal to 48. You can't go on the ride. Sorry, sis. So, the converse can be true too. What if you want to go on the kiddie ride, you're small, you're a little small fry, and we say, same thing, x, but x this time is less than 48. Notice the difference here. I don't have this line underneath right here. There is no line there. This blue sucks. That does not mean equal, so it has to be less than 48. So is 48 less than 48? No. 48 is not in the solution set for this one, but 47 is. Oh my God. 46, 45. Those numbers are all smaller than 48. So you could be anywhere under 48. That is what the solution set would look like for a less than. An action. So here we go. We talked about what an inequality was, what the solution set was, and we're going to show that graphically. So graphing an inequality is representing the solution set on a number line. So what I want you to pay attention to is your x. Remember, x is not one number. There is not one number that satisfies this solution. It's many. So for this one, we read it out loud. I always like to talk to myself, I'm a little crazy. We got x is less than 3. So what that means is all numbers that are less than 3 work. So 2.9, 2.8, negative a million. Anything under 3 works, but not 3. So what I like to do is draw a number line with at least 5 tally marks, and I always put my number that I'm checking in the middle. So I'm going to put an open circle at 3 because it's a less than. Less than equals open circle. So does greater than. Open circle. Open circle means you get really close, but you don't touch the butt. Shout out Nemo. So, what we do then is we're going to graph this. So what I like to do, you could, like a lot of people draw over the line. I don't like that because it gets messy. It's hard to see. I go up and over. So less than. So first I got to put my numbers. So I have 3 here. Use a different color. I use 3 here, and then I think about a number line. 4, 5, 2, 1. 1, 2, 3, 4, 5. Which way am I going to go? A la izquierda to the left. So that means all numbers that go this way and keep on going this way make that inequality work. X is greater than or equal to 10. Same thing. 5 numbers. 10 to the right gets bigger. 11, 12, left gets smaller. 9, 8. Now this one's a little different because it's an equal then. It's an equal then. That means it's going to be a closed circle. So greater than or equal to or less than or equal to make a closed circle because you actually do touch it. So in this case, 10 is part of the answer. So we're going to get a closed circle at 10. And then which way do we go? What numbers are greater than or equal to 10? Is 9 greater than 10? Definitely not. But 10.5 is, 11.2 is, all the way that way, up and to the right. To the right. We good? Over here, negative numbers, don't trip out, don't trip out. We got negative 3 in the middle. Now check your number line knowledge. To the right gets larger, so the negative number gets smaller. We have negative 2, negative 1. On the left we have negative 4, negative 5. What type of circle is this going to be? Well, you look over here, open circle because it's not equal to, so x has to be greater than negative 3. So the only numbers that make that true, that count for it, have to be bigger than -3. So we put the open circle at -3, and which numbers are bigger? To the right. -2, -1. -4 is smaller than -3, that doesn't count. For x is less than or equal to -14, same concept, drop your numbers in. It's going to be a closed circle. Which numbers are smaller than or equal to -14? Well, it's not -13 because we know going to the right makes a bigger or a larger number. We're going to go to the left. So -15 works, -16, -100, on and on and on. So that right here, guys, this is how you graph inequalities on a number line. Let's get it. So now we're going to solve inequalities. So solving inequalities works just like equations, except there's one little difference, and we'll get to that on this problem right here. So what you do is you isolate the variable, you get the x by itself to get the inequality. X is greater than whatever or less than whatever, and then you make your number line to represent the possible solutions. So for this one, this is real basic. X is +2 is less than 10. How do you get rid of x? Well, I like to train track it. I'm going to subtract 2 on both sides using the subtraction property of equality to keep it balanced. We get x is less than 8. Now, that's one way to represent it. This definitely works, but I like seeing that graph to go along with it. So we make our 5 numbers, 5 tallies, 8, 9, 10. To the left, we have 7 and 6. What kind of circle is this going to be? Open. It's just less than 8. So then which way do we go to say which ones are less than 8? Left. We should do like an episode like this, like Dora. It'd be amazing. So, we're done. That's it. Here we go. X divided by 3 minus 2 less than or equal to 4. How do you get x by itself? This is a 2-step. Hit that 2-step. We add 2 to both sides. That's the APE, addition property of equality. We get x divided by 3 is less than or equal to 6. How do you get rid of division? You do the inverse operation, which is multiplication. Put both sides in parentheses. Always do that. Multiply by 3 on both sides. 3 divided by 3 makes a 1. We simplified a 1. That's gone, which is what we want. So we get 1x. The x is by itself. Less than or equal to 18. Once you see an inequality like this, you know you can graph it. That's what we want to do. So you draw your number line. You get your 5 numbers. 18's in the middle because that's your solution number. That's going to tell you if you go left or right. What type of circle is this going to be? Closed circle because it is equal to, so it can touch the 18. So 18 is a part of the solution set. We go left. So for example, you must be less than or equal to 18 to apply for this school. You must be less than or equal to 18 to go to this party. If you're 19, stay away. Should be really 17, but hey. All right, 3x minus 4 is greater than 17. Let's get through that real quick. Train track. Add 4 on both sides. Now while I'm doing these, guys, if you think, oh, I'm starting to get this, pause the video, do the math on your own, and then press play and check it and see if you got what I got. 3x is greater than 21. Can we close the door? Animals are coming. We're going to divide by 3 on both sides because we got to cancel out that multiplication using the division property of equality. We get 1x is greater than 7. Greater than 7. So what numbers are greater than 7? Well, 7.1, 7.5, 8, 9, 10, 11. So we graph that. 7, 8, 9, 6, 5. What type of circle is it going to be? Open circle because it's not equal to. So that means 7 can't be a part of the solution. It's got to be bigger than 7. And that's going to be 8, 9, 10, 11, and all the way up to infinity. Those numbers fit. Last one. This gets a little tricky, so pay attention here. Do it the same way you always do it. Add 2 on both sides. I don't know why I'm loving this 2 right now. And in fact, I'm going to change that because this is going to give me a slightly messy number. So I'm going to change this real quick. Forgive me for that. We'll just make it a positive 2. Subtract 2 on both sides. We're going to get negative 5x is greater than or equal to 20. Okay, how do you get x by itself? We divide by negative 5 on both sides. We know that. Remember, we're not looking for one answer. We're looking for the range of answers, the many numbers. Now, here's the thing. Do you see this? No. You're dividing by a negative 5. When you divide or multiply by a negative number, you gotta write this down. Pause it. Play it slowly. When you multiply or divide by a -5, you flip the sign. You flip this sign, and we'll go through that later. But if you don't, believe me, graph it normally, and you'll see your answer don't make no sense. So instead of saying x is greater than or equal to, now we're going to flip it. It's going to be less than or equal to, and it's going to be -4. So what that's going to mean for our number line, that instead of going to the right, we're going to hit the Beyonce and take it to the left. So here we go. We got our closed circle at -4 because it's equal to, and we go to the left. So all these numbers that are smaller than -4 or equal to -4 are part of the solution set. Hopefully this video, I know I talk a little fast, you might want to go into the settings, drop that speed to 0.75, slow it down for yourself, or start listening a little faster. Inequalities represent a range, so if I need you to do at least 10 topics per week in ALEX, if I need you to go up a minimum of 3%, if I need you to have less than 3 tardies a week, whatever it is, things like that, that's all inequality, so it's all over the place. So I would like to get at least 10 new subs, so hit that subscribe button, like my video, let me know what else you need me to do. It's Mr. Hanson 414, I'm out.